Lesson 312, Mixed Practice. This is the lesson where it all comes together. Not introducing anything new, just reviewing the core skills of this unit. Multiplying and dividing fractions. Let's do this. Problem number 1, 9 times 1/4. Remember, when you see that whole number, let's start by rewriting it as itself over 1. So whole number 9 becomes 9 over 1 multiplied by 1 over 4. I'm going to pause. I'm going to check to see, is there any opportunity for cross-canceling? 1's here, 4 and 9. No, there is not. So I'll multiply across the top and across the bottom. 9 times 1 is 9. 1 times 4 is 4. We're at an improper fraction, so we'll convert this into a mixed number. 4 goes into 9 2 times, and 1/4 is the leftover amount. Next problem, 1/3 divided by 5. Again, when we see that whole number, let's rewrite it as itself over 1. So this will get shown as 1/3 divided by 5 over 1. Now remember, when we divide fractions, we'll keep what's on the left the same. We'll change the symbol and we will flip what's on the right. 1/3 stays the same. Division symbol becomes a multiplication symbol. 5 over 1 becomes 1 over 5. No cross-canceling here, so we'll multiply across the top. 1 times 1 is 1. Multiply across the bottom. 3 times 5 is 15. Final answer, 1/15. 7 divided by 1/10. Now, I should note that this whole lesson is a mixed review, so very important to pay attention to the symbol, the operation. Are we being asked to multiply or asked to divide? Let's rewrite that whole number 7 as itself over 1. Since we're dealing with division, keep what's on the left the same, change the symbol, flip what's on the right. And multiply across the top, 70. Multiply across the bottom, 1. 70 is our final answer. Next problem, we're multiplying. Check and see, do you see an opportunity for cross-canceling? If you notice the 3 and the 9, what's the greatest common factor that they share? If you said 3, you'd be correct. 3 goes into itself once. 3 goes into the 9 3 times. But wait, there's more. The 7 and the 28. What common factor do these numbers both share? 7. 7 goes into itself once. 7 goes into 28 4 times. And now we can multiply across the top. 1 times 1 is 1. Multiply across the bottom. 3 times 4 is 12. 1/12 is our final. 1/2 divided by 100. Let's rewrite that whole number as itself over 1. Let's keep what's on the left the same. Change the symbol from division to multiplication. And flip what's on the right. No cross-canceling, so multiply across the top. 1 times 1 is 1. Multiply across the bottom. 2 times 100 is 200. 1 200ths. 1/6 multiplied by 20. Let's rewrite that whole number as itself over 1. There is an opportunity for using cross-canceling here. The greatest common factor that goes into both 6 and 20 would be 2. 2 goes into 6 3 times, or 6 divided by 2 is 3. 2 goes into 20 10 times. Now multiply across the top. 1 times 10 is 10. 3 times 1 is 3. It's improper, so let's convert this into a mixed number. 3 goes into 10 3 times. 3 1/3. Moving on to the word problems here. A leaf weighs about, let me just read the directions at the top. Tell whether you need to multiply or divide, and then solve. Okay. A leaf weighs about 1/10 of a gram. There are 22 grams of leaves in a leaf bag. About how many leaves are in the bag? So let's visualize the situation here. We're talking about a bag of leaves that weighs 22 grams altogether. And we're told that each leaf weighs about 1/10 of a gram. We're asked to figure out how many leaves are in the bag. This sounds like division. We've got 22 grams of leaves. We're dividing that total amount into portions of 1/10 of a gram, because that's the weight of an individual leaf, to try to figure out how many leaves there are altogether. So let's rewrite this with the whole number shown as itself over 1. And then since we're dividing, we'll keep what's on the left the same. We'll change the symbol from division to multiplication, and we'll flip what's on the right. And now, no cross-canceling opportunities, so let's just multiply across the top and bottom. 22 times 10, 220. 1 times 1, plain old 1. We've got 220 leaves. 14. There are still 700 leaves on the ground. Of these, 1/5 are oak leaves. About how many of the leaves are oak leaves? Okay. Just for fun, I'm going to make a little visual model here. And we're told that there's 700 leaves on the ground, and of these, this fractional amount, 1/5, are oak. So what we're really trying to figure out here is, what is 1/5 of 700? 1/5 of 700 is 1/5 multiplied by 700. Let's show that whole number as itself over 1. And is there an opportunity to cross cancel? Well, yeah, there is. I'm not sure how fast I can do that as mental math. So for now, I'm going to get this to at least 700 over 5. Now, to simplify this improper fraction or convert it, I can use division. I will have to take 700 and divide it by 5. So let's do that. I'm going to use this space here. 700 divided by 5. 5 goes into 7 one time. 5 multiplied by 1 is 5. Then I'll subtract. 7 minus 5 is 2. 0 comes down. 5 goes into 24 times. 5 times 4 is 20. 0 comes down. 5 goes into 0. 0 times. 5 times 0 is 0. And there you have it. 700 divided by 5 is 140. That is how many oak leaves we're talking about. 15. A rectangle has a length of 6 feet and a width of 1/8 of a foot. What's the area of the rectangle? We know the area of a rectangle is length times width. Since we're given these two dimensions, we know multiplication is the name of the game here. The area is your length, 6, multiplied by your width, 1/8 of a foot. So let's rewrite the whole number as itself over 1. Look for an opportunity to use cross-canceling. 6 and 8 both share a greatest common factor of 2. 2 goes into 6 3 times. 2 goes into 8 4 times. Now multiply across the top. 3 times 1 is 3. 1 times 4 is 4. And area is going to be in terms of square feet here. So I'll show that by writing square feet or showing that exponent of 2. 3/4 square feet.